Well, hello. My name is Phillip Gentry, and today we're going to be talking about my project, the Candy Machine. So the problem that this project attempts to tackle is that in data science, we use metrics a lot to determine what models are good and what models are bad. But sometimes metrics alone are not everything that we need to get us where we want to go. Sometimes models can interact with each other, or people can change their actions based on what they're shown, or some models may just work better for some people in some situations. An example of this might be if we think about a model that predicts what a person might like at a grocery store. Let's say we have two models that predict what people may like in a grocery store. And one of them predicts that you're going to like broccoli with 70% accuracy. And the other one predicts that you're going to like chocolate with 70% accuracy. Which of these models is better? And what do we show this person as say, an advertisement? Do we show them broccoli or do we show them chocolate? If we show them both broccoli and chocolate, well, what if everybody just really goes with a chocolate then? And even though the broccoli model is actually 70% accurate, maybe they always just buy chocolate. Or maybe there's a health fad going on and everybody chooses the broccoli. Or maybe some people are there late at night looking for chocolate and some people are there shopping responsibly and looking for broccoli, and we actually want to learn what mode each of these people in our store is in and give them what they actually want based on what's appropriate to them. And so what I came up with is this simulation in the land of Wuzz. So Wuzzles were an idea from Michael Eisner back in the 80s. Disney did a whole thing. They were stuffed animals, whatever. But they were just kind of like a nonsensical kind of thing that popped into my head as a good way to simulate this problem. But basically, we're just going to try to create a artificial environment to simulate the issue that I just described. And then we're going to try to solve it using machine learning. And then eventually maybe reinforcement learning and some simple heuristics and hand-built algorithms. Spoiler, I haven't made it to that part. One important note is that in this situation, our candy dies. Wuzzles need fed, but candy needs Wuzzles. Some of the situations that we would like to simulate are going to be things that, say, matching algorithms, where say like for a ride sharing app, our riders need to get where they're going, but also if we want to keep drivers happy, we're going to have to find a way to distribute those drivers well and make sure that they're more or less happy as well. And so in our simulation, the candy dies. And that's how we kind of like tackle that problem. There are lots of other rules in the simulation. And you're welcome to read these in the slides later on or check them out in the repo. They're not super important for the talk, but yeah, take a look at them in the repo. So our candy machine sits between the Wuzzles and the candies, and it tries to figure out what the appropriate candy is for what Wuzzle, given that Wuzzle's particular mode. And so from there, we establish a baseline. Basically, when we build our candy machine, it accepts some modules. So those modules contain whatever logic is necessary for it to go through the candies and figure out what it wants to feed to a particular Wuzzle. And we start out with a baseline of a random.random candy. The simulations are all set up with 100 worlds, starting with 20 Wuzzles and 20 candies. And we see what happens pretty quickly is everything dies. We call this the Wuzzle apocalypse. And what we see here is a breakdown of the final day of 100 different worlds and what happened in those worlds. And so on the left, we have a dotted line representing the first day, the earliest Wuzzle apocalypse. So on some world, somewhere on one of these 100 worlds, on day 16, all the Wuzzles died. On another world, at least, it looks like day 21, all the Wuzzles died. But on average, day 18 is when the Wuzzles die with a random model. Another way to look at what happened in a simulation is this. This is licks per day to the end of the simulation. You can see here on the left, we have a bunch of basically overlaid bars. Each of these is an average number of licks per day on a given world. And they're just overlaid over on each other. And you can see like it starts out at a kind of a certain kind of like steady rate. And then as we use up all the candies, the licks per day go down, and then eventually the Wuzzles die with the same kind of layout that I described a minute ago. Earliest Wuzzlepocalypse, latest Wuzzlepocalypse, average Wuzzlepocalypse. So now that we have a baseline, we can take a look at what happens if we swap out our modules. So I put in a random decision, or I'm sorry, I put in a decision tree for our random module. And what you can see is that Wuzzlepocalypse actually happens a little bit faster. Down here at the bottom, you have a random simulation again for comparison. And so we have a Bernoulli naive base, a decision tree, and we see that the average day actually moves up considerably, which basically just tells us that our model is actually learning what our Wuzzles are eating, and it is efficiently feeding those Wuzzles. Unfortunately, at this time, what that means is the Wuzzles lick the candy faster, run out of candy faster, and die faster. So that's kind of where this model, or where this project sits right at the moment. The next steps for it are to increase the granularity of the simulation. I think there's a number of things I can add to just make it more realistic to the problem set that I want to tackle with it. And then I want to implement some more strategies. I think this kind of problem really lends itself towards reinforcement learning, so that our model is constantly actually getting feedback on whether it's doing the right thing for a particular Wuzzle. And then just build up some simple heuristics. I'd like to hand code some things and see if I could hand code some logic that would increase the life cycle of a Wuzzle. And these are things I just haven't had time to tackle yet. And that's it. My name is Phillip Gentry, and I'm a data scientist, and I'm also an engineer at Coffee Meets Bagel. And here are the links to the GitHub repo that contains the code for this project, as well as the slides for this presentation. Thank you so much for listening to me.